Hi, my name is Ken, and this is an intro to Koji Talk. I'm going to talk about the history of the Koji build system, what is Koji, and how do I use Koji. In the year 2005, I was just learning about this thing called Linux. A friend pointed me at this cool distro named Fedora Core. I remember installing Fedora Core 4, and that's when I really fell down the Linux rabbit hole. I found that there is this whole world of people that are building this thing called Fedora. So in 2005 and 2006, I'm learning how to install packages or build things from source, building things from source. I remember asking my friend who taught me Linux, "Hey, Chris," I said, "can you just SSH into my laptop and do that magic compile thing for me so I can have this cool app that I want? Because I can't get it with Yum." And my friend could have done it, but he was like, "No, you can figure it out." That was the best response that he could have given me, because even though it took days for me to figure out how to compile something with my laptop, it was another aha moment for me. So I went along through Fedora 5 and then 6 and then 7 in 2007. The light starts dawning that there are real flesh and blood people who are building this thing. In a lot of open source desktop apps, you can click the help button and then the about page, and it will list the name, email address of the person who wrote the application. Whoa! Coming from Microsoft Windows, where everything is very buttoned down, I had never seen anything like that. I had a similar realization when I was looking at an RPM package. When I run rpm-q-changelog with an RPM name, I could see the exact person who packaged that application for me. Coming from a world of Microsoft Windows, that level of transparency was amazing. In a similar way, I could run another RPM command, rpm-qi with an RPM name. This showed me the exact build host for this RPM. Whoa, what is this special breadhat.com host? I can't ping it, that's for sure. Blogging was taking off during this time, and I discovered a bunch of Fedora blogs that were all aggregated on one web page called the Fedora Planet. I could read all these blog posts about Fedora and Linux. So many of them were over my head, but I loved drinking in this strange world full of words and language that I barely understood. I remember coming across one post in particular in 2007. This was by Max Spevek, the Fedora project leader at the time. This post is still online today, and here's a screenshot. And I love the drama here. 3:55 a.m. May 31st in Raleigh, 9:55 a.m. May 31st in Berlin. Anyway, I've written previously on this list about the aspects of Fedora 7 that I think are the most important. From my perspective, it is the fundamental infrastructure changes that Fedora 7 represents that are the biggest achievement. The entire Fedora toolchain has been freed. Every step in the distribution building process is completely open. Code checked into an external CVS, packages built on a completely external build system, distros and live CDs built on completely open compose tools. All of this functionality is available in the command line via a graphical tool that is built on the APIs that we provide for folks who hack on free software. I hope that this is a compelling development environment in which to work for folks who are end users of free software. We believe that the Fedora toolchain allows people to remix Fedora and customize it in ways that will provide a much wider variety of Fedora-based spends than we could ever offer if Fedora release engineering had to build them all directly. What is Max talking about here? Well, there's broader things that are going on. There was the merging of Fedora Core and Extras, but Max is talking about a whole set of tools that are going to be open source. One of the most important ones is Koji. This was going to be the new build system for Fedora. Eventually, I stumbled onto the Koji web interface. Now, the UI looked a little different back then, but one thing I do clearly remember was that I could see what was happening in the build system at that moment. Live. I could see a bunch of developers' usernames and this section on the homepage. Now, Facebook and Twitter were barely born at this time. This was years before GitHub, where live activity streams were commonplace. This was magical because I could see Fedora being built in real time before my eyes. Many years later, in 2022, we still use Koji as the core infrastructure to build Fedora and a lot more. At a very high level, the way that developers build and ship Fedora looks something like this: dist-git, Koji, Bodhi, and the mirrors. So many Fedora developers all around the world push code into the centralized Git repos called dist-git for distribution Git. They build that code inside Koji. They use Bodhi as the system to gate and announce those build updates. And lastly, the Fedora infra team pushes those builds out onto Fedora's mirrors, and then users around the world can download the updates. In other words, all Fedora RPMs and the Fedora base container images must go through Koji in order to ship out to users. So what is Koji? It's the central build system for all of Fedora. The entire operating system and all of its packages are built within Koji. Internally, Red Hat engineers build all of Red Hat's projects with our separate internal Koji instance as well, so we also use Koji to build every single product in Red Hat. There are a couple of different instances of Koji out there. Obviously, the biggest public one is Fedora's Koji, so I'll mainly talk about that one today. What does Koji do? Koji does a lot of things. It has many features, and I like to sort those features into 3 basic buckets. So here are the 3 categories of what Koji does. First, it's a task system for farming out work to build artifacts on many different servers. Secondly, it's also a tag system for organizing all of those build artifacts. Lastly, it is an object store for retaining those, making them available to other tools in the release pipeline. Who uses Koji? In Fedora's instance, there are 2 levels of access. First, there are developers, and I fall into that first category as a packager in the Fedora community. Secondly, there are administrators of Koji, and these are the members of the Fedora community infra team. Koji scales well to hundreds or probably thousands of these developer user accounts. We have many packagers in Fedora, and they can all use the central Koji system according to some controls that a small group of administrators set up. Same thing for our internal Koji instance inside of Red Hat. We have several hundred engineers that all use one large Koji instance to build their products. How do I use Koji? Let's do a quick example of how I use Koji in Fedora with a small package. I'm cloning the GNU core utils package from dist-git here, checking out the rawhide branch for Fedora rawhide, and running the fed package build command. The output looks like this. I get a task ID, and my client pulls the system to watch my build progress, and after a while I get a line that says, "Success, your build completed, here are the RPMs." Well, how does that work? Let's break down what happens there in more detail. My Koji client contacts the hub and says, "Please do a build." And at that point, the hub tracks that work with a task ID number. The Koji hub assigns that work to one of the workers out of a pool of build servers. That worker clones dist-git and runs mock RPM build. Lastly, the Koji hub stores resulting artifacts. In our example, it's RPMs. Again, this could be other things like QEMU images or container images or whatever. Going back to that first point, when my Koji client, fed package in this case, initiates a task like the build task, it sends some parameters to the hub. It sends the package name, core utils, it sends the git sha from dist-git, and it sends the build target, the build route. I'll get more into that in a minute. 2 things I want to draw attention to while I'm here. Koji stores all our build artifacts for all products ever. It is essentially a large object store. And secondly, this is all centered around tasks. Tasks are everything in Koji, like the build task or the build container task. In this diagram, the Koji CLI is running on my laptop, and that talks to the hub to queue the new build task, and then the builders pick that task off a queue, do the work, and then store the result back onto the hub. This next slide breaks down what happens inside a builder. So Koji Builder is a daemon that invokes mock with a certain configuration. Mock is running an isolated chroot for that build, and the main process inside that is RPM build. RPM build takes an RPM spec file as its input and creates a set of binary RPM packages from that. Drilling down further, inside an RPM spec file, you have metadata like a package's name, version, release, and a set of instructions to compile the program, and then a list of files for that program. RPM build bundles those up into RPMs that you would install on your computer, and Koji archives those at the end. Now, in order to generate packages for multiple CPU architectures, Koji runs each Arch-specific build on dedicated hardware for that CPU architecture. So you can see x86-64 here, plus ARM64, PPC, and S390 are the ones that we have enabled right now in Fedora. That covers building, so let's talk about some overall design decisions in Koji. I love this sentence from the README because these 3 guiding principles sum it up: flexible, secure, reproducible. One of the foundational tensions in release engineering as a discipline is the balance between being flexible and being reproducible. When a build system is flexible, it's very quick to adapt, easy to change, meets all the new requirements for today and tomorrow. And when a system is reproducible, it means that you can still build that thing that you built 8 years ago. There's a video on YouTube called 10 Years of RHEL. In the beginning of this video, Paul Cormier talks about his first day in Raleigh.
In order to get there, we sort of started when I first started in my first day in Raleigh. I went to talk to the head of QE, and I said, oh, you just shipped a release. I said, certainly you can reproduce the release, and you know how to reproduce it bit for bit if we had to, etc. And he opened his desk drawer, and it was a bunch of CDs fell out, and he said, I think we got it in here somewhere.
So organizing content. Koji allows us to store content but also organize it with tags. There are two terms that you may hear a lot when discussing Koji or reading the docs: tags and targets. First, a Koji tag is a list of builds. It's a way to identify a particular set of builds. In the picture on the left, you can see the example Apple 9 testing candidate tag, and we have a few builds within that tag. The second term that you may hear with Koji is target or build target. This comes into play when you want to do a new build of a package like core utils, for example. A Koji target is a pair of tags. There's the build tag that identifies the list of packages that are inside the build route for the package you want to build, and then there's the destination tag. When Koji completes a build task, the build doesn't just hang out there unidentified at the end. Koji will tag it into a destination tag, and then that destination tag will feed the rest of the process, going on to make up the product or Fedora release. So if you hear these terms tag and target, think a tag is a list of builds and a target is a pair of tags. Why does this matter? Here are some examples. So in the layered product that I work on in Red Hat, it's Ceph, and Koji's build tags give us control over what's in our build routes. If we want to build against RHEL 7, we'll use a RHEL 7 tag to construct our build route. When we want to build against RHEL 8 or RHEL 9, we'll keep each of those separated out with different tags. In fact, internally we can even get more granular and track RHEL 8.5 or 8.6 with individual tags so that we can determine exactly what versions of RHEL we do or do not build against and what we do or do not support. The same thing happens with third-party projects like RPM Fusion or Apple or other projects where they need to track against specific Fedora or RHEL releases like RHEL 7 or 8 or 9. These tags allow us to organize exactly how Koji constructs build routes, or which builds to ship to which repositories. Again, this is one of the most fundamental challenges in release engineering. How do you support things very long term, sometimes on the scale of decades, while also supporting the light speed innovation that happens upstream in open source? If you've worked on a large project, you know that the more simultaneous branches of software that you want to support at the same time and continue to build, the harder that becomes because the world around you keeps moving forward. Like Python versions, Golang versions, GCC versions, they all change. Koji tags allow us to track all of those things at a very large scale. Some other use cases for Koji tags, so we want to identify, let's say, which builds out of the thousands of builds that our CI system performed actually promoted out and shipped to customers. Koji tags provide that many-to-many relationship for us to track those important builds among thousands. We often share builds between Red Hat layered products so that engineers from different groups can standardize on a common version of the SUM software. Garbage collection is another really important use case. When you run a large build system with hundreds of builds a day, you need to know what can I keep and what can I expire. The simplest garbage collection technique is just to save the last n builds or something. The difficulty comes when you have dozens or hundreds of product versions dynamically coming and going simultaneously. With Koji's tags, we preserve all the important builds, such as the ones that Red Hat shipped, while also deleting all the internal CI builds that never shipped and are too old for us to care about anymore. Koji has an entire microservice that handles garbage collection according to tags and rule sets. So getting back to tags versus targets here, there's a world of more confusing terminology that I'm just going to ignore in this video since it's an overview. If you're going to work with Koji though, it's best to study the docs in upstream Koji as best you can. Frankly, it can sound like another language sometimes, but basically the more that you study other concrete Koji implementations and read the docs, the more it will click. Next, I'm going to compare Koji to some other build systems and highlight some of the things that are unique to Koji compared to an out-of-the-box Jenkins instance or something else. In Koji, the hub, builders, and web UI are all completely separate servers. One of the key principles in Koji's design is that the hub is dumb. It's passive. The hub does not perform CPU-intensive or long-running tasks. Those are all separate daemons that run on their own, so they're separately scalable. One example I mentioned earlier is garbage collection. So garbage collection is a very difficult topic to configure and get right in general, and there is a separate daemon that does all the GC for Koji. The hub just responds to read and delete requests from that daemon. Same with the web UI. The web UI can even run on an entirely different server or set of servers from the hub. The hub is a simple, dumb, API-only RPC server. Another difference is that authentication is not native, so Koji does not store passwords for users. Instead, users sign in with Kerberos or client SSL certs. This can make it harder to get up and running with Koji easily, but on the other hand, in 2022, I think this has proven to be a good decision, with security experts saying things like, if you're writing an app today, don't store your own passwords, or even don't do your own auth, delegate it. Koji uses Apache modules to do authentication, and I'll cover that in the next video. Next, Koji puts an extreme emphasis on reproducibility. This is an opinionated experience. Almost all CI systems are heavily on the other side of that spectrum. If you think about GitHub Actions or something like that, it's very ephemeral, where you really don't care about what the build logs were like from many years ago. Koji is the opposite. Koji tracks everything everyone does because we want to preserve that level of auditing. When we say Koji is a tool for building operating systems, versions of an OS are built on previous versions of an OS. So in Fedora's case, for example, you can look back through the system to see all the versions of glibc that were used to build the rest of the distribution throughout history. Of course, this type of system is extremely good for security and poor for the type of small, lightweight systems that individual developers might have experience with today. Lastly, Koji's history is rooted in building RPMs, so Koji tracks everything about RPM content down to individual RPM headers. You can search individual files within an RPM, etc. As the years have gone on, Koji has developed the ability to handle arbitrary build types beyond RPMs through something called content generators, but that heritage of being extremely RPM aware remains. A few more features here as we tour through Koji. NVRs must be unique. What is an NVR? It's a name, version, release of a build. In RPMs, you'll find those fields in the RPM spec file. In containers, Koji and OBS get those from special Docker file labels. Regardless, once you've built an NVR in a Koji instance, you can never build it again. But wait, what if I want to do a build and I made a mistake in that one? That's fine. Just bump the release number and roll forward. Like in this example, I have 3 releases of the Ceph package version. 1, 2, 3 are individual release increments, and these unique identifiers make QE, support, and users happy. No ninja editing existing builds. Some other hard things to learn with Koji, like I mentioned, the terminology can be overwhelming. If you're setting up your own Koji instance, the out-of-box experience is very empty. I do recommend studying concrete Koji instances in the wild, like Fedora's instance or CentOS's instances. In order to set up a Koji system on your own, that out-of-the-box experience is something that I'll cover in the next few videos. And of course, Koji is an open source project with a mailing list, IRC channel, issue tracker that I've listed here. So, in summary, the main idea with Koji is stability, scalability, and making build environments extremely reproducible. For Red Hat specifically, Koji must reproducibly build all packages for products with lifespans of sometimes 10 years or more, meaning RHEL 5 all the way to RHEL 9.0. It's very complex to keep old versions of software building while also building the latest and greatest, and Koji is one approach to managing that complexity. Koji has a lot of history, some things are needlessly complicated, it's quirky with a lot of sharp edges. On the positive side, like many other things, it's also highly available and stable. So that sums it up for Intro to Koji, a cornerstone of building and delivering Red Hat, Fedora products, and many other things. In the next video, I'm going to do a deep dive on how authentication works with Koji. See you in the next one.